Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would start right away. Okay. 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 It's 3 now. We would start at 3-1 or 3-2. Okay. We would just wait for 1 or 2 minutes, then we would proceed. Okay. It's 3-1 now, so we should start. Okay. So let us understand yesterday's problem of the day, that is minimum operations to convert A to B. Okay, this problem came in Codenation as well as in Google. Good. Let us proceed forward. Okay, so let us understand the problem statement now. We are given two arrays A and B of length n and m. Okay, so A has length n and B has length m itself. Okay, good enough. Find the minimum number of insertion and deletion on the array A required to make both the arrays identical. Okay, so there are two options available. First one is insert, the next one is delete. Okay, the next one is delete. So array B is sorted and all the elements are distinct. Okay, this is absolutely very important. Okay, this is absolutely very important. Array B is sorted and the elements are distinct. Okay, so upon looking the problem on the first view, okay, suppose upon looking the problem we can see that this is a variation of a standard dynamic programming problem. That what is this, what are the states? The states would be the current element, that is size of the element n and m, and we would be seeing that if a dash n minus 1 is equals to a dash m plus 1. Okay, let us see. Okay, so if you have done the problem of this problem is a kind of variation of standard DP. Okay, so we can see what is the standard DP solution of this. Okay, so we have to make this recursive. So start building the recursion. What would be the return type? We can see that return type would be the number of insertion and deletion, minimum number of insertion and deletion. Good enough, fair point. So we would do int, the return type would be int. Okay, and name of the function, I name it as rec. Okay, and there would be two things, that is n and the second thing is m. Okay, n and m. Okay, let's try the recursion one. So okay, so if n is equals to 0, then we need to return m. Okay, why return m? If suppose the string 1, suppose if the string is empty and the second string has a b c, then the only option that is available is either we add a b c, okay, or we remove a b c, so that both becomes blank. Okay, so in either of the operation both is considered as 1, so we can directly return m, the size of the other string, simply. And if m is equals to 0, that is the other way around, we would return n itself. Good enough? Yes, that it is absolutely true. Okay, how and why I would say. Okay, now suppose the last two characters are matching. Okay, suppose we have a b c and then suppose c b and suppose c. Okay, so we can see that if the last character is matching, we won't touch the last character, and we would say that yeah, last character is okay, give me the answer for the rest of the characters. Okay, this is absolutely true, and we won't encounter any charges. Okay, good enough. Are you okay? Yeah, Vamsi ji, thanks a lot. I thought that my chat is not working. Okay, so let me again refresh. I think okay, yeah, so good enough. So let us proceed forward. So we can see if the last characters are matching, we can tell that, yeah, please recursive for the rest of the string. Good enough. So what we would do is, if s dash n minus 1 is equals to t dash m minus 1, okay, then what we can do is, answer is equals to recursion of n minus 1 comma m minus 1. Okay, just recurse it for the rest. Okay, now if it is not matching, okay, what are the options that are available? The first option that is available, if there is not a match, if there is no match, there are two options available. First one is insert. Okay, first one is insert. Okay, first one is the insert. So if suppose A, B and C, here we have A, B and D. If we need to just insert this character, suppose this character is not matching, we want D here. So what we can say that, yeah, we would insert this D. Okay, so we can see that we have found a match. Okay, and the remaining length that is needs to processed has been decreased, but this remains the same. So we can say that answer is equals to min of, okay, min of recursion of, the first one would remain the same because we are just adding it. So n and m minus 1. Okay, and then what can be the other way? The other way can be delete. Okay, so let us now start deleting these things. Okay, so now suppose we have A, B and C, and then suppose we have A, B and B. Okay, so now suppose the strings are, we are deleting it. So now suppose we are deleting this. Okay, so we can see that we have found a match for this one. Okay, so now this time the string of first is reduced, but the string of second is still the same. Okay, so it might be the, okay, just let me clarify this. Suppose we have A, B, B, okay, and A, B, D. Okay, so suppose D is not matching here. So the first option that we have is, we can delete this element. Okay, we didn't need to delete this element, so that we make both the equals. Okay, so now this time after deleting this element, this has increased but this has remained the same. So now we would just write this n minus 1 comma m, and we would add 1 because insert and delete both has a cost of 1. Okay, and we would just return this answer, return the answer. Good enough. Now what we would do is, we would simply memorize this. Okay, how we would memorize this? We would simply memorize this by making an array of dp dash n and m. Why n and m? Because we can see that the value of n can be 0 to n and the value of m can be 0 to m. Okay, good enough. So we would make an array of n to m, initialize everything with -1 in the main function or the solve function. Then what we would do is, we would just add a one-liner thing, that is memorization. If dp dash n dash m is not equal to -1, then return dp dash n dash m. Okay, and just before returning the answer, save it in the dp dash n dash m. dp dash n dash m is equals to answer. Okay, good enough, clear? Okay, first we would build the recursive solution, which is very easy to think, and if you are not able to think this and understand this, you need to have a good proper, and can you give a small recap from the very beginning? Okay, 8 minutes have already passed and discussion of one approach is already done. So if I start discussing from the very beginning, I would give you a recap, but that would be a small. Okay, so just other people, Pritam Hore, I would explain you quickly, but I expect a reply or a feedback from the other people that you have understood this or not. Okay, so now let us understand what the problem is trying to tell us. The problem is trying to tell us that we are given two arrays. Okay, we are given two arrays, n and m. Okay, and there are two operations, insertion and deletion, and both weightage is 1. Okay, why? Because it is told that insertion or deletion would be considered as one operation. So okay, so the weight is absolutely same. Okay, good enough. So now this problem looks like a variation of a standard DP problem. Okay, so what we would simply do is, there are two options available, insert and delete. So we would pass the size of each in the recursion, and the return type would be int. Okay, so now if the first string is empty, then the second string would be our answer, size of the second string would be our answer. Now if the second string is empty, the size of the first string would be our answer, because we can either delete the strings of the other string, or we can insert it. Okay, then good to go. Then what we are doing, if the last string is matching, we would say that yeah, last string is matching, do the matching for the rest of the string. Tell me for the rest of the string. We don't need to do any kind of operation for the last string. Okay, good enough. Now the next thing is that if there is not a mismatch, okay, if that is not a mismatch, okay, there would be an else. If this is not a mismatch, what we would do is we would either insert. If we insert this thing, then we would see, if we just move back, you would see that this would remain same and this got decreased, this would decrease and this would remain same, and every insertion or deletion is added 1, so we have added 1. Okay, and this minimum is stored in the answer. Yeah, absolutely, yeah. Now the next thing is that n's value is still 10 to the power 5 itself. Okay, and 10 to the power 5. So if you see the time complexity of this approach, then this approach would be n into m, that is 10 to the power 5 into 10 to the power 5. So 10 to the power 5 into 10 to the power 5 base are same, so the power would get added, so 10 to the power 10, and 10 to the power 10 is greater than 10 to the power 8. Okay, so you would get a time limit exceeded. Okay, you would definitely get a time limit exceeded. Okay, now we need to perform better than this. Okay, yeah, Siddharth, good enough. Now how can we perform better than this? Okay, I don't see any ways. Okay, I don't see any ways how to perform better than this. Okay, now the next thing that you should notice is, you can see that array B is sorted and all the elements are distinct. Okay, array B is sorted and all the elements are distinct. Okay, now talking about this, whenever you are told this in an interview, the first approach that you should give to the interviewer is this recursive approach. Now the interviewer tell you to optimize more, just memorize it. After memorizing it, suppose the interviewer now wants more modifications. Now how to do more modifications, that we would learn. Okay, good enough. Yeah, Siddharth, move on, we have understood. Okay, just quickly tell me that this is understood or not. Okay, most welcome Pritam. Okay, only Ankita Kumari understood or others also understood? Can I have a quick yes or no? Okay, so till then, just can you guess something with array B is sorted and all the elements are distinct? Okay, array B is sorted and all the elements are distinct. Okay, yeah, Siddharth, how can we do so? So just can we do this? See, 1 is here, and if we take the last one, that won't be possible enough, so this would be 1. Now 3 is here, we would just take 3 and this is 3. Okay, and then 5 is not here. If there is 5, then this is in between. Okay, this is in between. Either we can take 1 and 5, either we can take 1 and 3. Both has a length 2. If we take this, we need to insert 3 at the end. Okay, if we take this both ways, okay, so we can see both has a length 2, so we won't be able to figure it out. Okay, so we can see that this elements, if we just search it here, then it might be the case that we can solve it. Okay, yeah, Siddharth, kind of looks like the solution. Okay, so let me tell you this. Okay, array B is sorted. Okay, so this is array B and this is array A. Okay, let's start putting the values of A1. Okay, suppose I have 2, 3, then 5, then 7, then 7, then suppose I have 9. Okay, and the elements here are 2, 5 and 9. If the elements are both sorted order, so what we can do is we can just search this element in this. Okay, so search this element in this, search this element, and this element, and we would just remove the rest of the element. Okay, yeah, Siddhartha, we can do so. We would remove this element, we would remove this element, we would remove this element. So the number of deletions would be 3 and the answer would be 3 for this. Okay, yeah, Siddharth, good enough. Okay, but if the test case A is not guaranteed that it is sorted, what to do in that case? Okay, So let us try to do that. A, okay, and B now, okay, and let us give a sorted array to B. Okay, suppose the sorted array is 2, 5 and suppose 7. Yeah, so that's good enough. So suppose we have 7 this time here, because it is not told that A would be sorted, so it might be unsorted. Good enough. Whatever wants this. Okay, suppose we have then 2, again 7, okay, again 7, and it is not guaranteed that A will not have distinct elements. Okay, A will not have distinct elements too. Okay, so might have duplicates. Okay, so now suppose again we have 2, 5 and 7. Okay, so now if you do this, suppose you are searching for 2. If you search for 2, this would give you this. If you search for 5, this would give you this. Okay, if you search for 7, this would give you this. And this is not in the order. This is not in the order. 7, 2, 5 is not equal to 2, 5, 7. Yeah, Siddharth, true. What would we do? The other way is to find the first index. Okay, find the first index. Okay, Siddharth, let us try to find the first index. Okay, if we find the first index 2, so we would load this 2, load this 2. Then we have suppose 7, so we would load this 7, we would load this 7. Again we have 5, and this is ruining our answer. Okay, so this can't be solved like this. Okay, so now we would be learning a way to length of longest increasing subsequence. Okay, longest increasing subsequence in n log n time. Okay, now for the people who are getting confused that why this problem is now this, okay, I would let you know this. Okay, so this is 2, 5 and 7. Yeah, Siddharth, this is 2, 5 and 7. True. What we would do is we would count this 2, 2, then 5 and then 7. If we just report this index, that is 3, then this is our answer. Okay, good enough. Now Siddharth, it might be the case that the A element might have element which is not equal to the element that is comprising of B. Okay, now let me do that also. Okay, so we have the scenario of A and B. Okay, and the elements are 1, 5, 7, 9, this type of elements, and the next element is 1, 5, 7 only. Let's keep the A sorted so that we would tell this. Okay, so now what we can do is we can take out all the elements which are there in B, because B consists of distinct elements. So we would take this element, we would take this element, we would take this element. Okay, so we would take 1, 5 and 7, and we would take 1, 5 and 7, and the elements which are not present in B, we won't take it. Okay, and if we bring out the longest increasing subsequence from this, that would be our answer. Not final answer, but our preliminary answer. So what I want you to say is, okay, जो A 157 में नहीं है, जो 157 में नहीं है, we need to delete these things. Okay, we need to delete. Okay, so जो B वाले A में नहीं है, उनको हमें delete करना है. The elements of B, okay, the extra elements in A which are not in B, we need to delete those elements to convert it into B. Extra parts needs to be trimmed down. Simple thing. So extra parts trim down. Okay, trim extra. Okay, the next thing is this, that we need to find the longest increasing subsequence, because yeah, suppose after trimming this is 157. Suppose yeah, this is trim the extra, the elements which are not there in B, we need to trim that. Yes, that we have trimmed. Suppose after the trimming part, the elements of B is 1, 5 and 7, and the elements of A are, can be like this, 1, 1, okay, 1, suppose 7, okay, then again 3, okay, not 3, it won't be having the elements which are not there, and suppose again I have 1, 5 and then again 7. So we can see that the element this would be mapped to this, and this should be mapped with this, and this should be mapped with this. So this 7 should not be mapped, this 7 should be mapped. Okay, so this would be 1, 5 and 7. Okay, and then we need to remove all this. Okay, so the problem is now finding longest increasing subsequence. Okay, better than this. Okay, so this is a dynamic programming way also, but we would be doing in n log n. Okay, n log n. So I would start discussing this. Okay, just let me again open it because it has just now crashed. Okay, so before I start discussing this length of the longest increasing subsequence in n log n time, are you able to tell that why the length of longest increasing subsequence in n log n time is required? Can you tell me how we are coming to this? Okay, I tried this, but it's okay. What happened if we find the longest common subsequence and find insert? What happened if we find the longest common subsequence? And what happened if we find the longest common subsequence and find insertions and deletions? Yeah, you can do that too. But how can you do that better than n square? That is the main problem here. Okay, we won't be waiting 15 minutes, lol. Okay, so we would be waiting for just 1 minute. Okay, so I would be giving you a quick recap instead of waiting. The thing is that we were having A and we were having B. The solution till now is that the elements which are not in B needs to be removed. Okay, so we need to remove the elements which are not in A. Okay, remove extra. Okay, so we need to remove the extra. Now the next thing is that we need to find the longest increasing subsequence because B is sorted. So if B is sorted with distinct elements, this means that longest increasing subsequence, we need to find this and then find LIS. And then after that, what will we do, Siddharth? After finding the LIS, the answer would be like this: A minus LIS, okay, A minus LIS, okay, plus M minus LIS, okay. So that would be n plus m minus 2 into LIS. This is what we would do. Can you quickly tell me yes or no? Okay, this is the quick review of what we have learned. Okay, quick recap. Okay, quickly tell me. I would be waiting for the next 1 minute. If you have any doubts, if you're not understanding, let me know the part from which you are not understanding and I would tell you again. Okay, Nankita Kumari, thanks a lot. Okay, now to find the LIS, what we do? Okay, now to find the LIS, what we do? The algorithm to find the LIS in n log n time is the. Can you repeat this LIS method? Yes, I would be explaining you LIS. Okay, I would be explaining. This is left. This part is left, but coming to this part is what we need to do. Okay, so now the thing is that how to compute the LIS. Okay, computing the LIS is absolutely very easy. Okay, we would build a vector, blank vector. Okay, or else I would take an explanation. Suppose the input is 1, okay, 1, then suppose 5, okay, then suppose 2, and then suppose 7, and then suppose 3. Okay, good enough. So the answer of this is 1, 5, 7, okay, or 1, 2, 3. Okay, both. So what we would do is we would remove this. Okay. Okay, or else let's take a better example. 1, and then let's take 5, and then let us take 2, 3, and 4. Good enough. Okay. So what is the algorithm to find this? Okay, 0, 1, 2, 3, 4. Just understand this and you would be able. Just simple example. So what we would do is we would insert a blank vector. Okay, blank vector v itself. Okay, so the first element would be inserted without any worries. Okay, the first element is inserted now. So we are at the index 1. If the current index element is greater than the last element of v, we would insert it. Okay, we would insert it. Okay, now the next thing is that it is coming 2. It is coming 2. Whenever we get an element which is less than the last element, what we would do is we would find that position of the element. If it is available, if it is not available, we would find the next greater element. Okay, so what is, if 2 is available? No, 2 is not available, only 1 and 5 is available, Siddharth. Okay, so the next greater element of 2 that is available is 5. So what we would do is we would replace this 5 with 2 now. Okay, and then we would come to 3. Yeah, 3 is greater than the last element, so we would write 3 here, and then again 4. So yeah, 4 is greater than the last element, we would insert 4. This is the algorithm. So if I write the algorithm, okay, insert A0, okay, then we would see the back. If v dot back, the last element of v, is less than ai, that is the current element, what we would do is v dot pushback ai. Okay, else what we would do is we would simply need to search that element or the element which is greater than that. And what can and how this can be implemented very easily? This can be implemented very easily by using lower bound. Okay, lower bound easily. Okay, so we would do the lower bound of this. What we would do is we would find the element that is lower bound. Suppose after returning the lower bound of ai, it returns id. So what we would do is else lower bound lb ai, and it would return me id, integer index, and I would write v dash id is equals to ai. Okay, and at the end I would just return v dot length. Okay, when can I, okay, I would now show you the code itself. Okay, how is the code that is looking? So we would return the integer here, we would return integer here, and we are taking vector as an input. What we are doing is, if the vector dot size is greater than 0, we are pushing it the first character that we are told. Then we are starting our iteration from the rank 1, that is index 1. If the index 1 is greater than the last element, we would simply push it, else we would just find the lower bound of it, and the rest dot id is equals to the current element. At the end, if all these iterations is complete, we would just return this value, and this would give us the longest LIS length. Okay, longest LIS length. Okay, I should be clear with this, but I expect a yes or no from here. Okay, so now what we discussed was we would first remove the extra and we would find the LIS. Okay, so how we would remove the extra? So we can see that if we just find each element, okay, find each element in B, because B's array is sorted, so we can simply do a binary search, and if we found that element, we would insert this in TP. Okay, so we would search each element. If this element is present in BI, then we would simply insert it in BI. Okay, TP. So we are doing that. If it is present in B, we are inserting it in TP. If it is present, अगर वो present है तो हम लोग TP में insert कर दे रहे. Then we are finding the LIS of TP, and then what I am doing, n minus lis, okay, plus m minus lis. So bracket खोल देंगे, n plus m minus 2 into lis. This is what we were doing. So this is what I am doing here too. Okay, I am doing n plus m minus 2 into lis of t. Okay, now let us talk about the time complexity of this. Here we are doing a time complexity, or this loop is doing a time complexity of big O of n, and for each I am doing a log n. Okay, log n, because binary search has a time complexity of log n. So the idea would be n log n. Okay, good enough. Now moving forward, how we are taking out the lis, we are taking out the longest increasing subsequence. Let's see how we are doing it. We are first pushing back it. This is order of 1. Okay, then this is vector of size, so this is big O of n. Then what we are doing is, this is big O of 1, and at max, at the worst, it is big O of log n. So for every element we need to search, that is the most worst case. So time complexity of to find this is already n log n. So n log n here too, and n log n here, there also. So time complexity would be n log n. That is 10 to the power 5 into log of 10 to the power 5, which is less than 10 to the power 8. So this would pass. Okay, this would now pass the problem statement. Okay, now am I clear with this or not? Can I have a quick yes or no? I would be starting a timer of absolutely 1 minute. If I get any doubt, I would be resetting this timer. If I don't get any doubt for the continuous 1 minute, then I would be turning the session off. Okay, if you have any doubt, please let me know. Why? Because you are investing your time to learn here, and I am investing my time here to teach you here. So if you are not learning, and if I am not able to teach properly, then we both are wasting our time. Okay, because our goal is not completed. So if you are not understanding, let me know. Okay, and I would also know that where I am lacking. Please let me know. Okay, as the stream is delayed by 20 seconds. Okay, okay, so I would be resetting the timer again. If I don't get anything, I would be turning the session off. Thank you Vamsi ji, thank you Pritam Hore, thank you Ankita Kumari, thank you Parminder, thank you Talent Next, thank you Parminder for attending the session. Thank you and have a nice day. Okay. Today I will be getting a call with you, sir, on LinkedIn. Okay, sure. Okay, sure. Okay, now before turning this session off, there is a small announcement for you. Okay, let's go to the problem. Okay, let's see what is the announcement here. Let's go to courses. Okay, so now I would be turning this session off, but before turning this session off, there is an important announcement for you. Okay, let's go to live classes. Okay, now the thing is that there is a course on data structures with C++, which is designed for the people who want to master on data structures. Okay, and the beginners who have no experience in programming are welcome here. Okay, and in this course we would be learning all the implementation and mastering data structures, like implementation with stack and all, the implementation of segment trees and also everything. And you can see all the syllabuses here, and I am the course instructor, and this is my credibility. And talking about the demo video, you know that how I teach and what I teach. Okay, and if you are having any doubts regarding this course and you wish to buy it, okay, then you can, and if you want to have a one-to-one conversation before buying this course, then you can just click on this LinkedIn button, and you can go to the LinkedIn and you can have a talk with me. Okay, and you can resolve your doubts. And if you wish to buy this course, then you are most welcome. Okay. Sir, is GFG conducting any competitions or hiring challenge? Yeah, GFG is conducting competitions or hiring challenge. Yeah, it is conducting. Okay. Definitely you're not wasting time as we are able to understand your approach. Yeah, thanks a lot. Okay, yeah, it is conducting. Okay, that's good. That's all for today. Thank you and have a nice day. If you didn't understood anything after this stream, then you can connect with me on LinkedIn and I would be more than happy to explain you where you didn't understand. Okay. Thanks a lot. Have a nice day.